kind of an engagement, or rather a platform where we can all participate. So I came up with a question, and the question is, you type in the comment section what is your favorite tech or automation tool, because again today's topic is about infrastructure as a code, and I wanted us to, you type in the comment section your favorite tech or automation. Oh, Terraform, yeah, I see you, James. So yeah, I want you to get to do that. Yo, yeah. I see you, I see everyone's talking about Terraform. So yeah, so let's do that in the comment section. Just before I introduce our today's speaker, I realized she just joined us. Sam, what is your favorite automation tool?
I was just about to type chat GPT. But anyway, I'll go with I've recently seen the power of Copilot. I don't know if, okay, it doesn't fall squarely into the automation, but it's sort of a way of evening the development of code. So the Copilot, GitHub Copilot.
Okay. Albert, could you tell us your favorite or your automation tool, your favorite tech tool?
Okay. Hello, everyone. To my side, I'll say PowerShell. I do a lot of scripting using PowerShell. So, yeah, on my end, I can say PowerShell.
That's cool. Pauline, I've seen Pauline. Pauline, what's your favorite?
I put mine in the chat. The Terraform Club. Yeah, so automation of infrastructure as code. Yeah.
Okay. I saw James. Who else? Faith, could you tell us your favorite automation tool? And Macreen as well. I'm expecting the speaker today to also tell us her favorite automation tool. Let's do that in a minute. So guys, continue typing the tool that you feel like it's a favorite tool in the chat box. And I'm really happy and honored to have the chance to introduce our today's speaker, Macreen Musimbi. She is a technical consultant at QED Solutions, and she is a DevOps engineer. And we are looking forward to learning a lot of stuff from Macreen Musimbi. So we are also fortunate to get insights regarding infrastructure as a code from her. So kindly let us give a warm welcome to Macreen Musimbi as she takes over the virtual stage. So Macreen Musimbi, the floor is yours. Welcome.
Thank you, Mutua. I'm happy to be here with you guys, and today we're going to talk about infrastructure as code. That's DevOps mostly, and I hope everyone is excited about it because it's the best thing in the world, I think. Yes. So I'll share my screen, and then we can start the talk. Yes. Can you see my screen? I hope everyone can see my screen. Yes. Okay. If you can see my screen, you can just okay, you can see your thumbs up or anything. So nice. So we're going to talk about, infrastructure as code in DevOps. So I don't know how many guys here know what DevOps is or infrastructure as code, but for those who are beginners in DevOps or the tech world or infrastructure as code, what I can say about DevOps is that I'll try to use layman's language as much as possible. So DevOps is just like there is.
Sorry, Macrain. Sorry to interrupt you, but there's someone called Daniel Clement who is struggling to see your slides. Could you kindly enlighten them?
Sorry.
Yeah.
Okay. Let me just make them big. She's famous. Let me just share again.
Yeah. Kevin is suggesting how about going into slideshow mode?
Okay. Okay. I'll do that.
Okay.
Yes, that's better. Just a minute. Let me just share my screen and then go to slideshow. I hope everyone can see my screen. So yes, there it is, our slideshow. So I was talking about DevOps. So DevOps is the one, okay, should I say the thing that bridges the gap between developer and operations? So DevOps is a lot of things. So I won't explain it in details, but that's basically it. DevOps between developer and operations. So infrastructure as code, just like the word says infrastructure as code. That basically means that you have, let's say, we have developers, we have front-end developers, we have back-end developers. But now you already have the code. Now you need people to use your website or your application. Of course, you need to put that code somewhere in the cloud, of course. So in that cloud, you need infrastructure. So you either go to the cloud, if it's AWS or Google Cloud or Azure, and create the infrastructure manually using the console, or you can do an easy thing. You can write code to deploy that infrastructure for you with just simple commands. If it's Terraform, you just need 3 simple commands. Yes, so that's infrastructure as code. So infrastructure as code is just what I've said in layman's language. Okay, it's the ability to help you provision or deploy your infrastructure using code. And what is code? Code is, it's just, let me say, machine language. It's like you're telling your machine to do something and it does it for you. So that's code, writing something that commands the machine to do something for you. So as you can see on the screen, we have some infrastructure as code tools. We have Terraform, Ansible, CloudFormation, Puppet. There are a lot of tools and most of them are friendly. Okay, technically, all of them are friendly. That's all I can say. It only depends with your preferences. Like for Terraform is widely used and it can be used with any cloud. You can use it to deploy resources to AWS, Google Cloud, Azure, Ansible. There is CloudFormation. Now CloudFormation is only for AWS. We have Puppet, and for Azure, we have Azure Resource Manager. For Google Cloud, there it is. We have Pulumi, yeah, Chef. We have all those tools that you can use for infrastructure. Let's go to deploy your infrastructure. So let me show you a sample infrastructure that maybe you want to deploy. I hope everyone can see this image. So this is basically, it's like the whole thing, an infrastructure. So we have the front end, the back end, and the databases. So someone will come to you. Let's say you're a DevOps engineer. A solutions architect has mapped out everything that you need to deploy your code. And the developers have done their work. They already have the code. But now the infrastructure needs to be ready, to be up and running, all the resources and everything to be configured. So you've been given this diagram. And of course, it will have more details about maybe the VPCs, the subnets, and the everything. So you, as a DevOps engineer, you need to deploy this. So you have let's say two choices. You can either go to AWS and start creating things one by one. You start creating an EC2 instance, one EC2 instance, then create another one. Now you see, you'll have to create, like from this diagram, you'll have to create 4 EC2 instances. And that's okay. Okay, to be honest, that's a lot of work. You can't like create 4 EC2 instances. What if you need 10 and maybe you wake up tomorrow and you have a lot of users? There is a lot of traffic. Now you'll have to add other EC2 instances manually, and that's a lot of work. Okay. So the best way to deploy this, you just need to write a few lines of code, which is very interesting, by the way. And with those few lines of code, you'll be able to deploy the whole infrastructure. And in case there is any error, you'll be able to backtrack in your code and find where the error is specifically. And it's easier to solve errors, and you can decide to scale your EC2 instances easily. You can create this infrastructure to maybe 5 other companies or 10, just using the same code base. Maybe you'll just change a few things, of course, maybe the security keys and the access keys and all that. But it's way easier writing the infrastructure as code other than going to AWS to deploy all these resources. So if you have a question, you can always ask. Yes. So benefits of infrastructure as code. For infrastructure as code, the processes will be automated. Everything is automatic, but okay, not everything, but once you write that code and write those 3 commands, that is Terraform. Okay, for Terraform, you'll just need Terraform init, Terraform plan, and apply, and that's it. And after you do the apply, if it's for your practicing purposes or for maybe demonstration somewhere, you'll just do Terraform destroy and delete everything. So it's kind of easy using Terraform. Also, CloudFormation it's also easy, but because everyone here seems to like Terraform, we're going to use the word Terraform a lot. Yeah, so for automation, it's big. That infrastructure is called Terraform. It's good when it comes to automation. Like for example, let's say you work for a company and they want you to create maybe a launch template, and you have an auto scaling group, you have the EC2 instance and everything there. But now you're supposed to take your launch template when maybe the programmers they push code and something changes, you need to take a snapshot and create another launch template. So that will be easy if you just write a Terraform code that will, every time there is a change, you just run your Terraform commands and the launch template will be created automatically, other than going to AWS to create from scratch. So you'll be like, every time there is a change, you have to go to AWS to make a change. But it's easily done when you just code and reuse the code. Every time there is a change, you just run the command and everything runs. Yes, and it's very interesting, of course. So for scaling, maybe you need to add, let's say something, maybe a resource to your infrastructure. With Terraform, it's way easier to just add a line of code in your infrastructure and deploy it. And it will take like less than 10 minutes to deploy the thing you're trying to deploy. It's very easy. And also, for infrastructure as code, you'll be able to collaborate with your team. Let's say you're in a company, you have developers, you have other DevOps engineers. They are also good in Terraform. So you need to use version control. Maybe sample version control tools like Git, GitHub, yeah, Bitbucket. So for collaboration, if let's say you are in teams of let's say for DevOps you have 5 people and everyone has their own module. Maybe the first person should create the VPC. Let me just use that our image to explain it better. So maybe we have 4 people in that your company, 4 DevOps engineers. So the first DevOps engineer, maybe he's supposed to create a Terraform code that will deploy the VPC. Maybe that person is good in networking, so they'll better do it. And then the second person should maybe create a Terraform code that will maybe deploy EC2 or maybe the load balancer. You see, but now all your code should work together when it's up and running. It should work as one. So for collaboration purposes, it's best to use version control tools like Git and GitHub. And it's advisable, very much advisable for anyone who wants to be a DevOps engineer. Anyone who is a DevOps engineer, you should always learn how to use version control tools like Git and GitHub. It's very important, and it's kind of the base of a DevOps engineer. Even developers and most people who are in tech, it's best to know Git and GitHub. So for infrastructure as code, it's easier to collaborate with your partners to deploy services, maybe the infrastructure, and you can always use one code base. And yes, so let me go back to our slides. So for consistency, now in a company, you'll always find every company has their own coding style. Even as human beings, we have different coding style. You can see my code and you'll know like this is Macrin. You see someone else code, maybe Albert, you'll say like this is Albert, or maybe this is Sam or someone else. Yes. So like everyone has their own coding style. Let me say like a signature. Everyone has their code signature. So for every company, you'll find that maybe for their variables, they name them using maybe the first name is there, the company's initials, and then maybe underscore something. So like they have to be consistent in that. Like even if you are new in that company, you'll have to adopt their naming convention or something. So like you have to be consistent all the way to the end. So that's consistency. So for infrastructure as code, if there are previous people, let's say an example of a company, So there were previous people in that company. So maybe they were arranging their infrastructure as code. Maybe they were writing variables in one file and then the code in another file. And then maybe for VPC, there is a different file for VPC. For EC2 instances, for scripts, there is different files. So if you go there, you'll have to maintain that the way they were doing things. And for infrastructure as code, it's easier to actually be that consistency, You like your work will be easy. You just arrange it, break down the files, and always make sure that you're not doing something that's monolithic. Always try to decouple your project, even infrastructure as code. Like you can't write a whole code, maybe 20,000 lines of code just to deploy an infrastructure in one file. 20,000 lines of code in one file. That will be insane, and it will even be hard for people who will come after you. So it's way better to write, let's say, a minimum of 50 to 100 lines of code per file. So it's better to separate your files. Maybe this is a file for to deploy EC2 instances. This one is for VPC. This one is for my scripts. This one is for maybe another thing, auto scaling group, load balancer. It's way easier and it's much easier to read such code. And always, as a DevOps engineer or someone using infrastructure as code, always learn how to comment your code. As you write, please add comments so that even you yourself, maybe after 3 months, when you come back to your code, you'll be able to understand it. And for this infrastructure as code, you can always write articles. If you're a growing DevOps engineer, you can write articles for it too, so that the next time you get a similar job to maybe deploy something, a service, you just refer to your article and everything will work. Yes. So best practices. I think I've mentioned version control, which is very important. Anyone should know that. So for secrets, maybe passwords, are database, especially database passwords. In coding, I'll just in coding. So let's say you are a backend engineer, and in backend you have passwords. These passwords, maybe it's for a database. You don't want people to see your password. Maybe it's for the company, or I don't know, very important. You don't want people to see your secret. So the best way, if you're using infrastructure as code, let's use an example of Linux. Okay, I'm on a Linux machine. Maybe someone else can talk about Windows, but I'll talk about Linux. So like in Linux, before we push code to GitHub, even before we push code to GitHub, the first rule of coding, always make sure that your secrets are not exposed. So you'll have to use variables. And for good thing about Linux, you can use environment variables. I think even for Windows, there is also that. So for environment variables, you'll create a file separately, and maybe at least an example of Django. You'll have a .env file, and then in that, you'll create a maybe .gitignore. That's why Git is very important. So Git ignore, the files that you put in there will not be pushed to GitHub. So if you define your secrets in a .env file, they won't be exposed in GitHub repository or anywhere. And for AWS, of course, you can store your secrets somewhere. And it's very important that you always keep, let's talk about AWS, your secret key and access key secret. That's why it's a secret. So you should make sure that it's secure. So for Terraform, you'll create those variables, and in those variables, use other variables. Just don't type your secrets there. Don't expose them, because you don't know who will use that Terraform next, or someone might get your Terraform code somewhere or anywhere. And it will be really bad for someone to see your secrets. Another best practice in infrastructure as code, continuous testing. Okay, in everything you have to test. You have to do testing, 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 continuous testing, integration, and deployment. So you have to, if you write a small thing, no matter how small, even you can decide to test after every 10 lines of code. When you write a VPC, deploy it, test it, make sure it's working, and then go to the next one. This is easier because when you get an error, you know exactly where the error is. If you had 10 lines of code, it will be easier for you to debug 10 lines of code other than debugging 1,000 lines of code. So it's better to do it in bits, small portions. Another best practice is it's advisable to build in modules, of course. So, like in this diagram of ours, let me just go back to it. This diagram, surely you cannot deploy the whole thing like once, unless, okay, let's say you've written the code for the first time. You really cannot deploy it all at once. You need to divide it into modules. You need to plan. You need a plan. Actually, you need a plan. So maybe you'll start with VPC, deploy it, test it, make sure your code is working, it's clean code. You have comments and everything. And then maybe the next step you go to the subnets. After that, then go to meaning web servers, EC2 instances, the application server in bits. Go to Postgres SQL, deploy it, make sure it's working, everything is fine, and just do it step by step because there is no need to rush only to debug something for a few hours. Yes. Lastly, you should always learn how to scan your infrastructure as code. So we have these nice tools, and tools are everywhere. You can always use these tools to scan your code after you've written it. And I wrote some of them for you guys. We have Terraformer, we have TFlint, and the rest. You can always go to Google and search for them. And once you write your code, you can use them to scan your code and see if everything is working. So, yes. And there, okay, we have resources everywhere. Like for Terraform, there is HashiCorp, just like this page I've just shared. So let's say you want to deploy something. You don't have to struggle or guess. Don't do guesswork. We have documentation everywhere. Just make sure whatever you're writing is correct and your structure is nice. So if let's say you're a new person in Terraform, you can always go to their documentation and they have everything. Like for AWS, if you want to, maybe for EBS volume you want to do it, you have a code for it right there. Everything is written for you, and they even have explanations for everything, literally everything. So it's kind of easy to work with something that has a documentation. Even for developers, we have documentations everywhere, and documentations are the way to go. Of course, you can Google on YouTube and other things. So, do you guys have any questions before I continue? If you're okay, you can just thumbs up and then I can continue. Okay, it's like everyone is okay. That's really nice. So you can always use Terraform, HashiCorp. Another thing, let's say, let me just a second. Yes. So about this, it's advisable to always, if you're a DevOps engineer, if you write a code, you just document it. You never know where you might want to use it. Like for this document, it's about deploying this this whole infrastructure. It's a step-by-step deployment. So you can always go through it and try to deploy this whole infrastructure. So lastly, not really lastly, for GitHub, I was talking about gitignore. Let me just show you. So for gitignore, if you're writing a Terraform code, of course you need a gitignore if you're writing it locally. Let me just show you from my VS Code. I had already opened it. So here it is. So you need .gitignore file, because when you run Terraform init, it will install this large files in your code. So instead of pushing everything there, you can always ignore them so that they can just remain locally. And this is what I was talking about, .gitignore. Let's say I'll just use an example. Maybe, not maybe, of course, you have a .env file. If you don't want it to be pushed for people to see, you can always put it there and save. So if you come here and create a .env file, you can always define your secrets there. Maybe your password, database passwords, you can always define them there. And if you define them here, no one will have access to them. That's for developers and even you guys, okay, for DevOps and other people in tech. Always learn how to use .env and .gitignore. They're very, very, very important and very crucial. Another thing, as I was saying, about structuring your code. Like, for example, for this infrastructure, this is the code for it. Okay, I wrote it. Okay, it's my code. So, yes. So, when you want to structure your code, this is just a sample, nothing serious. So always learn how to write README files. They will help you. Like if you come here, you'll know like I'll have to run Terraform init, Terraform plan, and Terraform apply. Okay, though mine is very brief. Sorry for that. So when you come here, I started with a VPC file. And sorry, I'm talking only about Terraform, but it applies to other tools too. So for VPC, I decided to break it down into small portions. And if you look at this code, you'll notice that I have small comments, like maybe creating VPC. So when someone comes here, they'll know that this block of code, it creates a VPC for you. And then the next step, creating a public subnet. They'll know this one is for public subnet. So it's very easy for them to get and to follow the code structure. So like for this one, this one is to create a VPC and everything in it. And you can see it's 152 lines of code, which is, it's good because you can go through it and you can also debug it very easily. And then after that, there is the one for security groups. It's just the on file for ingress and egress rules. They're all there. For load balancers, backend, this is the backend load balancer. If you come here, it's very easy for you. Just that 2 lines of code. Very easy, well structured, understandable, readable. Front end load balancer, we have a launch configuration. Another thing, you need to know how to write scripts. You can always, coding is it's just not about coding. It's like, let me say it's like you're making commands to something to make work easier for you. So you can always write scripts to do anything, literally anything. So like for this script, what it does, it runs for me an update in my EC2 instance, and then it installs some softwares, and then I install Docker in it. I create a user and add that user to a group. Okay, that's for Linux. And then my image is in my ECR repository. So of course, I pull the image using this command, and then I run the Docker command. So like when I run this Terraform code, it will deploy for me everything. What I'll have to do is to just go find the domain that I need to run on my Chrome, and then everything will be working. I won't have to do anything else. I'll just run Terraform in it, plan and apply, and everything will be up and running. So like, for instance, we were talking about automation. So like, if you're in a scenario where you have to run, okay, to deploy a Docker image, Docker, your code is in Docker, so you have to deploy it. So, and it's maybe in an ECR repository. So technically, if you're not using Terraform, you'll have to go to that ECR repository, pull that Docker image in your EC2 instance, and install. First, you need to install that Docker in that EC2 instance, because the EC2 instance, it always comes when it's very clean. It's very clean. It has nothing installed in it. So you'll have to do these processes manually. But with Terraform, just write one file, 3 commands. That's it for you. And everything will be up and running. Yes. So this one is for backend, a backend application in Docker, of course, which is already in an ECR repository. So another important thing for all DevOps, you need to learn how to write scripts. And with Terraform, you can do anything. Like for here, I've just written this script, and of course, I'm referring to it in my launch configuration. Like for this one, okay, there is launch template, launch configuration. There is one that is outdated, but it's all the same thing. So for this launch template, it will always refer back to my script, my front-end script. You can see here that I've called it. You just define things and call them. It's very easy. You don't have to struggle. So instead of writing this whole code here, I just wrote it here and called that code here, that file, and that's it. It will always run. Just 15 lines of code. It's very easy. For backend, I did the same thing. Yes, right here. Very easy. So you can always write scripts and call them. Like for example, maybe you want to run something, and for that thing to run, you need maybe to run commands somewhere. You just write a script, call it in that maybe Terraform code, and it will always run it. It's like from top to bottom, it will always run. Yeah. Uh, any questions up to there? If you have any question to there. Before I go to the last thing, very last. If you don't have questions, just thumbs up. Yes, you just define things and call them. Very easy. No stress. James, go ahead.
Yeah, sorry, McCrane. I have one question around maybe could you talk on variables? How are variables important, especially in Terraform or in code?
Okay. Well, okay. First of all, okay, I'm not sure if everyone knows what a variable is here, but a variable, it's like calling something, okay, maybe calling something X, and maybe that's your name, maybe Macreen. So your variable here is X. So that's a variable. And the importance of variables, when you define a variable in Terraform, like in one place, you have the variables in one place, you can always call them in another place. Like, I don't know if I created some variables for these things. Okay. Yes. Okay, so I'll just give you an example, a simple example. Yes, like this one. Okay, though this one is, yes. So for this code, I'm trying to look for a simple one, like maybe, let me just go to the top and refer to the VPC ones instead of going to NAT gateways. Yes. So for this code, let me just highlight this one, meaning the importance of variables and the meaning. So for this one, I created a resource AWS VPC and called it CloudForce VPC. So when I want to create a public subnet, of course, a public subnet should be in a VPC. So you need to define it. You need to tell your Terraform that I want this public subnet to be in this specific VPC, because maybe you'll have a few VPCs. So when you come to define your public subnet, you'll call your cloud VPC. So this is like calling a variable. Okay. Though not exactly, but it's like calling a variable in something. And this variable, it's a whole VPC which has parameters like ID. If you give it a name, it has a name, so you can call it. And the most, okay, ID is very important because it's always unique. Always. It's the primary key for everything. ID, even in development, we always use ID as the primary key. It's very unique. So in Terraform, you can always choose to write a file defining all your variables there. And then when you come here, you can always call those variables. Maybe you want your VPC to be in something else. You can use the where you named your variable, maybe the VPC, you can call that variable X to be here. Now this one maybe you are calling X. X was your VPC, so it will be X dot. You want to use the ID, so you just call it like that, and it's very easy because they are in one place. You don't have to define. Sorry. So you don't have to define your variables all the time. You just define them once and you use them dynamically. They'll not be static. I hope you guys understand what I'm trying to say. Yes. Any other question? If you have any. Okay, everyone is okay. So one last thing I wanted to say, okay, or rather share. So you can always go online and look for these resources. There is a YouTube video that you guys can check and learn this Terraform thing. And you can always reach out. And it's nice to collaborate on projects. Maybe you know something that I don't know. It's nice when you collaborate on a project. You might teach me something, I might teach you something. One last thing, as DevOps, always have maybe workload. So like maybe every maybe let me say bookmark it or mark it somewhere so that you can always track your progress, write articles, work in teams so that you can learn the skill, collaboration, and many other things in DevOps. Okay, so I hope next time I'll have more time so that we can actually run the Terraform code and see how it's working in real life. And of course, there is a YouTube video for that. You guys can check it out. But you can always create another meeting and do it in real life. Yes. Thank you. Thank you. I'm done. Thank you. Unless you have questions. Someone. Yes. Let's just
Oh, sorry about that. I do have a question. I would like you, first of all, thanks a lot for that amazing presentation, Macrin. I think I've honestly learned a lot here, this one. And I'll just ask you to maybe outline if someone is new to infrastructure as code or wants to start out in infrastructure as code, like could you just map out a roadmap? Where do they start and which resources does someone rely on?
that's that's a nice question. Hey, I love that question. So for beginners, you are in the right place. So first of all, as a beginner, you need to have VS Code because you need to do these things locally by yourself first before you get employed and deal with the big machines. So you have to start small. First, make sure you have VS Code. Another thing, make sure you have GitHub, and make sure you have Git. Install Git in your machine. And for Windows, I know they have Git Bash. They can always use that. And then another thing, let me just show you guys. Let me share my screen once more. I'm sorry about that. It's just that I enjoy talking about DevOps and can take longer. So let me just share my screen and quickly go to it. So as a DevOps engineer, you can see my screen. I have a lot of bookmarks, and most of them are just coding stuff. And another good practice, if you run into an error and you find a solution to it, and maybe it's online, always bookmark that article. It will be helpful somewhere. So let me just find that YouTube video for here it is. I bookmarked it. So this guy here, let me just post it. Step one, and these videos are very short. Okay, they're not like 5 hours long. You can see from here, they are 4 minutes, 5 minutes, and all that. So this guy will start with fundamentals, and then he will teach you how to create an IAM user. Of course, when you come locally, let me just show you guys. So this is your clean VS Code. Let me just open another clean folder. Okay, sorry about that. Let me just open a folder. Okay, here it is. So maybe Terraform. Hmm. Yes, this is a clean folder. Let me just delete this one. So you can always, okay, you should always use VS Code. It's nice, it can support a lot of things. So like for this one, just come to extensions. Make sure you have these two extensions, AWS and Terraform. Just come there, search AWS, and you'll see AWS Toolkit. Click on it, install. Another one is Terraform. These things are there. Terraform, click on it and install it. Just like that, simple. And then this guy here, I don't know his name. This person here, okay, he walks you through literally everything. And by the time we get to maybe 20 video, the 20th video, you'll be like, let's say 60% Terraform guru. So let me just share this link to these videos. So you guys can start here. It's really quick and simple, and he demonstrates everything. But make sure you have VS Code, GitHub, Terraform installed, and AWS extensions, and IAM user whom you use to push because normally, just like the normal way, when you go to AWS, you need to log in as a person, maybe an IAM user or a root user. So the same way, when you come locally, when you want to deploy EC2, you need to be identified as a user. So you need to have access key and your secret key locally. so that when you push changes, it will show that maybe it's user Macreen who pushed these changes. It's really nice. And yes, that's it. Is it okay, Sam?
That was super cool and some very good direction that you've given there. So I can't thank you enough. And yeah, that was an amazing presentation. Thanks a lot. So back to you, Aurelia.
Yes.